Hi, my name is Sarah Jessie, and this is my submission for EECS1021 bonus project. I've built a system that combines a digital clock, a calculator using Java, Arduino, and the Fermata library. This project supports the engineering grand challenge of tools for scientific discovery. By combining hardware with Java software, the system demonstrates how we can collect and process information in real time. My hardware components include my Arduino Uno, the OLED screen connected over 12C, a buzzer connected to the digital pin D5, and everything connected via USB. My software components include Java for the main logic, Fermata 4J library to control the Arduino directly from Java, and the desktop live software for Arduino, which helps me monitor the Arduino pins in real time to verify that the buzzer and the OLED work as expected. Now let's start with the digital clock. This system fetches the current time every second and prints it out to the console. In addition, the buzzer is programmed to buzz every 5 seconds for 1 second. Using Java's timer tags, the buzzer pin is set to high, it stays on for 1 second and turns off. With the desktop live software for Arduino, I can visually confirm the pin behavior, seeing the signal rise and fall on pin D5 every few seconds. Also, I can visualize the time using the desktop live. Now for the calculator, the user interacts through Java console, entering numbers, choosing operations like addition, subtraction, multiplication, division, or trig functions like sine, cosine, and tangent. Once the calculation is done, the result is printed on the console and displayed on the OLED screen. I'm using Fermata 4J's built-in support for SSD1306 OLEDs to draw the results on the screen. A timer tag refreshes the OLED every second to show the latest results. And to ensure the system works reliably in real time, I created a unit test using JUnit. This allowed me to verify that key functions like the clock and buzzer behaved correctly and consistently. This unit test helped validate the digital clock update every second and the buzzer went off as expected. It also made it easier to debug and reset the system during testing. To connect the hardware and software, I used Fermata 4J, a Java library that communicates with the Arduino. This IPI lets my Java program send and receive data directly to the pins and 12C devices like the OLED display and the buzzer. For time formatting, I use Java's simple date format, which helps structure the live time display into readable fields like hours, minutes, and seconds. To efficiently display and compute information, real-time data management and user input processing were implemented, and the desktop live clock software to display the live time. This desktop software integrates seamlessly with the Java application and updates in real life time, making the clock more interactive and user-friendly. I also use event-driven programming, especially for the user inputs. When a user enters a number or selects an operation, the system responds instantly, updating the display and processing results. Event-driven design was also used to activate the buzzer when needed and refresh the OLED display. It ensured the calculator outputs appeared instantly on the screen. I followed object-oriented programming principles throughout the project. I organized the calculator logic into reusable, manageable classes, helping to separate concerns and keeping the codes in order. Object-oriented programming made it easier to expand and improve features. For example, adding more operations or enhancing display logic didn't require major rewrites. Overall, the project combines hardware and software in real-time systems that respond to user interaction. The integration of a buzzer, OLED, and desktop display shows how embedded systems can provide intuitive user feedback. Thank you for your attention. Looking ahead, there are several exciting possibilities to enhance the system, such as adding more advanced mathematical functions, improving error handling, and even introducing wireless connectivity for remote control and monitoring.